Good morning. I am Dr. L.Bharathi, Professor in AC Department, Sri Shanmukha College of Engineering and Technology, Sangagiri.
Introduction. What is communication? Communication is the process of conveying information from one place to another place. The communication is mainly classified into two different types. One is wire communication and another one is wireless communications. In wire communication, the information can be transferred through copper cable, twisted cable, TV coaxial cable, and even optical fiber. Example, telephone communications, TV cable communications, and optical fiber communications. In wireless communications, the information can be transferred through air. Air is a medium here. Example, amplitude modulation, AM communication, FM communication, satellite communication, radar communication, and mobile communications, etc. Next, here optical fiber is a medium or channel which carries the information in terms of light. Light is also called as electromagnetic energy. The optical fiber is support for the frequency of 10 to the power 15 Hertz. It is nothing but optical frequency. The optical fiber belongs to wired communication system. The optical communication system is having lot of advantages compared to all other existing electrical communication system. As follows, it has more bandwidth and support for more data rate. It is having no electromagnetic interference and low loss. It is having more channel handling capacity because of more bandwidth. In addition to that, this system is more flexible and easy to maintain and less weight. These are all major important advantages of optical communication system. Now let us see optical fiber structure, which is shown in diagram here. It consists of different layers. The first layer, that is a medium known as a core, which is shown here as a silver color. It is having the refract index 1.5 because it is made up of silica glass. Then the core is surrounded by cladding, which is lesser refract index than core medium, that is denoted by N2. Then the cladding is surrounded by coating. The coating is surrounded by strength member. The strength member is surrounded by outer jacket. These three layers, outer jacket, strength member, and coating, is protecting core and cladding from any damages. This is a fiber structure. Next, we go for different types of optical fiber. There are two different types of optical fiber available. One is plastic optical fiber, another one is glass optical fiber. The plastic optical fiber can be used only for short distance communication, whereas glass optical fiber used for very long distance communications. In general, either plastic optical fiber or glass optical fiber, further it is classified into three different types. The first one is single mode step index fiber, the second one is multi-mode step index fiber, the third one is multi-mode grid index fiber. In single mode step index fiber, it can be used for very long distance communication system. Example, nowadays we have connected a link from country to country and continent to continent. Even undersea cable system have already been established. Whereas multimode step index fiber and multimode grid index fiber can be used for short distance communications because of due to intermodal dispersions. Example, a local area network and wide area network, it can be make use of that. Now let us go for the fiber structure diagram. The first diagram shows single mode step index optical fiber. It consists of two different refract index N1 and N2. N1 is nothing but core refract index, N2 is nothing but cladding refract index. Then core refract index N1 is always greater than cladding refract index N2, which is shown in the diagram. So since it is a single mode fiber, it support only for one mode, which is traveling through center axis of the fiber, which is shown here. Then what do you mean by step index fiber? The refractive index of the core media is constant throughout the core, and the refractive index is suddenly changes into the cladding, abruptly changes into the cladding or step changes. So called it is a step index fiber. Then the refractive index profile of single mode step index fiber shown here against to the fiber structure. Since N1 is greater than N2, the refractive index profile of the core media is more than the refractive index of the cladding medium as per the diagram. Now let us go for the diameter of the core and cladding. The diameter of the core is around 8 to 12 micrometer, whereas diameter of the cladding is around 125 micrometer. It can be used for long distance communications. Next, we go for multimode step index fiber structure diagram. Again, this type of optical fiber consists of N1 and N2, two different refractive index material, core and cladding. This type of fiber can support more than one mode. Even now, we can see light rays traveling two different mode, which is shown in the diagram. So called it is a multimode fiber. As we know already, what do you mean by step index fiber? It is nothing but refractive index is a constant throughout the core medium and suddenly or abruptly or step change into the cladding medium. Now the refractive index profile of multimode step index fiber shown against to the multimode step index fiber. Again, N1 is greater than N2. The core refractive index is greater than the cladding refractive index as per the diagram. Now let's go for that diameter of core and cladding. Diameter of core is around 50 to 200 micrometer and cladding diameter around 125 to 400 micrometer. By seeing single mode step index and multi-mode step index, the core diameter is much more greater in multi-mode fiber than the single mode fiber. By seeing the fiber structure itself, we are able to identify whether it is single mode or multi-mode fiber. It is possible. Now let us move to third diagram, that is called it as a multi-mode gradient index optical fiber. Even this type of optical fiber consists of two different refractive index medium N1 and N2. And this type of fiber support for more than one mode. Even here the light rays traveling through two different mode. So called it's a multi-mode. What do you mean by gradient index optical fiber? The refractive index of the core media is gradually decreasing from center axis of the core to the surface of the core. Then the refractive index is abruptly, suddenly changes into the cladding medium. So there is a gradual changes in core medium. So called it is a gradient index optical fiber. The refractive index profile of gradient index optical fiber is shown against to the fiber structure. N1 is greater than N2. The center part, that is a core refractive index, is gradually decreasing towards cladding medium from center axis of the core. Now let us see the structure of the core diameter and cladding diameter. Core diameter is around 50 to 100 micrometer and cladding diameter is around 125 to 400 micrometer. This multimode fiber can be used only for short distance communications. As I said already, it can be used for LAN and WAN network. Now we go for ray theory transmissions. How light travels through optical fiber. The light travels through optical fiber based on total internal reflection. How total internal reflection occurs when the light traveling through optical fiber. Let us see, when the light is traveling from one medium to another medium, the Snell's law come into picture. As per the statement, when the light incident on the interface of two different media, N1 and N2, at an incident angle theta 1, the light get refracted into N2 medium with an angle theta 2. Theta 2 is nothing but refracted angle. This relationship between incident angle and refracted angle is known as Snell's law for refraction. Therefore, N1 sin theta 1 equal to N2 sin theta 2. This Snell's law can be explained in detail based on the diagram shown below. The first diagram shows here the light incident on the interface of two different media, gas and air, at an angle theta 1. That light get refracted into air medium at an angle theta 2. Then second diagram, it shows when the incident angle is exactly equal to critical angle, at which the refracted light will be traveling only along the interface of two different media by the time the theta 2 become 90 degree. So therefore, when theta 1 equal to theta c, theta 2 equal to 90 degree. This is called critical angle. Critical angle is nothing but angle at which the complete light will be traveling only through interface of two different medium. Then third diagram shows when the incident angle slightly more than the critical angle, the complete light will be reflected internally back to the same medium. So called it is total internal reflection. Therefore, total internal reflection occurs only when incident angle is greater than critical angle. Now, the critical angle and total internal reflection can be explained in terms of expression. As per Snell's law, n1 sin theta 1 equal to n2 sin theta 2. When theta 1 equal to theta c, theta 2 becomes 90 degree. Substitute theta 2 equal to 90 degree, n1 sin theta c equal to n2 sin 90. Therefore, n1 sin theta c equal to n2. Now theta 1 becomes the critical angle theta c. Therefore, the equation for the critical angle theta c becomes theta c equal to sine inverse of n2 by n1. Therefore, when theta 1 greater than theta c, the complete light will be reflected internally back to back in the same medium. This phenomena is known as total internal reflection.